All right, so with that, there was my history of New Mexico's bridges and what we have in our inventory. So now I'm going to talk about what I was initially slated to, and that's our bridge preservation program. So hopefully I can tie it all together, and I haven't lost any of you yet. So looking at our inventory, we have 3,700 NBI bridges. About 3,000 of those are DOT owned and the rest are local. And then we have just over 25,000 NMDOT lane miles in our inventory. So now that graphic, I brought it back up. So now that I gave the history of what kind of went into this, and when you saw those, the main bridge construction being done in our state, now you can see that most of the stuff we're trying to preserve was in that 50s, 60s, and 70s time frame. And like most Western states, we're limited with our funding, and in the last few years with increased costs, it's getting even tougher and more of a challenge to preserve and replace these bridges. So even with bridge formula funds, which has helped, it doesn't really increase how many bridges we can address, just because New Mexico, we've seen a 50% per year increase in bridge costs, and last year was over 100% increase in costs. And that's due to just material shortages, labor shortages, and a lot of challenges. So this graphic is of our poor bridge inventory, and it goes back to 2002. So in 2002, we had about 300 bridges that were in poor condition. And New Mexico has tried to address poor bridges through preventive maintenance and preservation to try and stretch those funds that we have. So we established a program which I think was unique at the time to focus on bridge preservation, but I think a lot of other states have started doing similar. But you can kind of see now we're down to 124 poor bridges that we own. Our preventive maintenance program, like I said, in the early 2000s, there was starting to be a focus on bridge preservation just because the cost to replace bridges, you can't do too many replacements. So to stretch those funds and keep our bridges in place and servicing the public, we focused on preventive maintenance. Up until about 2015, we were using federal funds to do price agreement work and preventive maintenance work, but that kind of changed, and it shifted to being more done with preventive maintenance was being done with state funds. And in 2013, the DOT established a program where they took $14 million off the top of the state budget to set aside just for bridge preservation and maintenance. And it was put to the Bridge Bureau and the state bridge engineer to use the condition ratings and the condition data from inspection to determine priorities for what bridges should be focused on that year. And then we're looking at it in 4-year intervals to do bridge priorities. But again, we didn't have a lot of state funds at the time, so the breakdown was $12 million was federal funds, and that focused on the NHS bridges, and then about $2 million of state funds was used for the non-NHS bridge structures. So in that time frame, we've done a good job of decreasing the amount of NHS bridges in poor condition, but not a lot of focus on non-NHS. So when we received the bridge formula funding last year, I made the determination that we should take some of that money, since you could use it on the non-NHS, and focus some of it to the same type of bridge preservation work. So I think we're receiving $45 million a year. We're going to take $11 million of that and focus it to the non-NHS bridge structures, and help to bring those the number of non-NHS in poor condition down. One of the things that we've ran into with our priorities as far as preservation and have turned into emergency repairs is bad joints and bad bearings. The other things that we focus on a lot with this money is deck sealing and deck overlays, and then just concrete repair. So 2 of our methods of doing preventive maintenance, we do state funding price agreement work. And the advantage of this procurement is that we can get 3 bids from contractors pretty quick. They come to an agreement on materials with the districts and quantities, and then we can issue a work order right away. So if there's an emergency situation where we need work done quickly, this is the best method to procure that, but it does come at a higher cost. The other method we use is through just doing typical book projects using state and federal funds. The advantage of these projects are we get them typically designed and built for a lower cost, but again, the disadvantage is the length of procurement, and it doesn't really help out when you have an emergency repair where a bridge is impacted and needs to be opened up quick. I don't know how many of you have seen the Terminator Salvation movie. So like I said, the movie industry is big in New Mexico. This was one of the first big blockbusters that was filmed in New Mexico, and through CGI they were able to blow a car up on the bridge. So don't worry, the bridge is safe. But if you haven't seen the movie and now you might be interested in seeing it, so you can see the Taos Gorge Bridge with its explosion on it. Okay, so I'm sure a lot of western states have the same issue we have. We see a lot of thermal cycles. Daily, we have a temperature delta from 40 to 50 degrees, so our bridges move daily. And when things don't move, problems start to occur. Due to lack of funds and manpower, unfortunately, we have bearings, steel bearings that have become problematic. And within the last 5 years, we've had several significant bridge bearing failures that we had to do emergency repairs and even shut the roadway down. We almost lost a couple of spans, and Rio Bravo over the Rio Grande River just south of here was one of the first ones, happened the day before Christmas. I was out there, had to shut the bridge down, and the local traveling public was not too happy about it. They moved the barriers and tried to cross the bridge anyway, and I got to stop traffic, and they yelled some nice four-letter words at me and some of the other DOT staff, so that's how I spent one of my Saturdays. But due to that, and after that, we've seen more of these. But as you can see in that upper right photo, I don't know how many of you have heard the concept of thermal arching, but basically when our deck heats up, which is a big element, absorbs a lot of heat, it arches. If you have pre-stressed girder ends that are restrained, you get tension and compression or axial forces in those beams, and now you have a beam column, and then you get those forces going into your cap, which causes bearing problems, cap failures, and what you're seeing there in those photos with those cracks, broken anchor bolts, bent anchor bolts, stuff like that. So here's a photo of I-25 over Gibson, just south of here. And this is one of the first ones I got brought into. I was still consulting at the time, but through the on-call, they brought me in to come up with a repair for this. And as you can see, there's a pretty large crack at the end of this cap, caused from that splitting force. And this was kind of exacerbated by the way it was designed. The designer didn't put at the end of the cap, there was no steel stirrups. The first one is 14 inches in from the end, so there was nothing there to resist cracking, so that's why that crack opened up. But it did get the attention of the news. Everyone that's local knows Larry Barker is the investigative reporter. He had it on a story, so they got me out there to look at it, and I kind of took a three-step approach to repairing it. The deck joints needed replaced, but because it was so locked up, I wanted to stabilize the substructure first, so we did epoxy injection in the cap, which you can see in that right photo. Then after that was put in place, just took it a step further. We fiber wrapped it to encase that and just confine it. And then due to not having the shear stirrups in the end, we took it a step further and actually put steel plates on each side with all thread rods above and below the cap to tie those plates in. In the right side is a photo from District 2. Jonathan Boyle, he's here today. This is one that his crew did to repair a similar type problem that they had. And they did that with their local forces. So this has kind of been one of our standard go-to details for repairing these. Again, with the thermal restraint, we had some bad details. Earl has some of these bridges. Well, this is one of his bridges, but he has several of these in his inventory, which we've kind of worked on some of them. This one's a local county bridge, or a local government bridge, but it has a shared sole plate. So again, they were trying to do a steel continuous type detail when they designed it. The girder wants to rotate with that arching, and it splits the girders. So we have a lot of girders that have split on the ends that have this type of shared sole plate. And then there's not really any bearing there. The designer decided not, I guess they used like a 1/4 inch or a 1/2 inch thick unreinforced elastomeric pad. and these are type 63 girders, so it's a big bridge, big span. So a lot of force is generated and causes problems. So like I said before, other preservation activities that we do are a lot of deck sealing and deck overlays. So it's probably familiar to a lot of you, just flooding the deck, putting down the epoxy, and then the broadcast aggregate, which you can see the finished product in that upper right photo. Jeff Vigil, my bridge management engineer, wanted me to discuss these photos here and just highlight them. I know him and Earl have gone to these different preservation meetings and bridge management meetings, and some states have a limit on how much bridge deck they'll repair or patch. New Mexico, we'll take it to about 90% before we replace the deck, which you can see in this photo. So we'll take it as far as we can before we replace it. And again, just some more concrete repair. Older bridges that were built during the interstate building, they had widely spaced stirrups in the pier caps. So we get a lot of concrete spalling and delamination. And there was attempts to repair it, and it just did the same thing again. So we go in and add additional reinforcement, which you see in that left photo, to give that concrete something to bond to. And that's worked out successfully for us. And then again, in the upper photo, just the amount of deck patching that we will do and have had to do on the interstate. And then again, I just want to mention steel. This is a recent steel bridge that we did preservation on. It's been hit. This is at Grants over I-40. We raised the bridge, put it on pedestals, did heat straightening, and then coated it, and then put a new bridge rail on it. So the final pictures on the left after the repairs, and on the right you can see the bridge prior to preservation. Other challenges, like I said, we have a lot of bridges that were built off those timber standards in service still. In the left you can see where an overload went over one of those bridges. The interstate traffic was rerouted on a local route. These timbers were split. We had a dropped span where a 1,000-year flood event pushed debris up against the pier piles, loaded it like a dam, and snapped the piers, and the span dropped in the middle of the night. Luckily, the ADT here is like 30 cars a day, and nobody drove off into that before they could get it closed. And then with the bridges that are over the Rio Grande that are timber, we had some inspection done and found out we have marine borers that actually act like termites, I guess, and eat up the piles. Again, another one of our standard designs that were built during the with those bridge standards developed early on are adjacent reinforced concrete structures and box bridges. The joints leaked, and that's one of the biggest issues we get is leaking joints. As you can see, the bottom flange of these channel girders has delaminated and fell off, and then you get a lot of corrosion on that reinforcement. So we're focusing on trying to replace these bridges because preservation really doesn't work well for them now. Another unique thing for New Mexico DOT is we also own railroad bridges. We have 120 railroad bridges in our inventory. Most of them are timber structures, and they have the same issues. The ballast holds and collects water, starts to rot the timber deck. And then we get high flow events like shown in the right photo, and you get debris buildup and silting. We've had to shut down the rail line for like 24 hours to get it cleared out, but railroad doesn't like that. It services several Amtrak trains a day, so they get on us to keep that open. And finally, some of the issues that we have with our oil and gas industry is we have a lot of fracking. I'm not sure if all of you have seen this, but if you haven't, here's one of our 14-axle coil tubing units that cross through our state. This one weighs about 350,000 pounds, so you can imagine the amount of stress this type of load puts on our bridges. And this isn't an infrequent load. This is a routine, daily, weekly load that we see primarily down in the southeast portion of the state. Luckily, we don't have as many span bridges there. We have mostly culverts. But we have had some bridges that have become headaches for us that we have replaced just to carry these loads. This is what you typically see at a fracking site. You have coil tubing units, generators, hydraulic controls, and cranes, and all of these loads are heavy permanent loads. And then I thought I'd throw this one in here. We do get this once in a while. This is a 1.8 million pound load that went through the state several years ago. And again, you can imagine the amount of stress this produces. So I'm a little bit over on time, but we're pretty close to the end. Jeff Veal wanted me to throw this out there. The biggest challenge for us is, do you pick red or green? Or if you're like me and you can't decide, you go Christmas. So hopefully tonight you can enjoy some good local cuisine and a margarita and some sopapillas. But again, welcome to New Mexico. Thank you all for getting through this with me. And if you have any questions or anything, let me know. And have a good one and enjoy your time. Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.